Welcome to the Empowering Tomorrow's Automotive Software Podcast, brought to you by ETAS, a single source of cutting-edge software and hardware solutions that make automotive embedded systems safe, smart, secure, and sustainable. Each episode, we'll be joined by ETAS and industry experts to discuss how electrification, automation, and connectivity are impacting the automotive industry. Now, sit back and enjoy the discussion.
Hello, my name is Janak Patel, Technical Director at ETAS in our embedded middleware solutions space. For today's episode, we'll be talking about vehicle software. As vehicle software becomes more complex and need for secure solutions increases in the automotive market, close collaboration between hardware and software vendors is critical to ensure we are ready for the SDV challenges. ETAS and Infineon collaborate to optimize security, performance, and functionality of next-generation microcontrollers. In this episode, I'm joined by Hugo Ochoa, Product Marketing Manager from Infineon. We'll take a look at how the collaboration between ETAS and Infineon can benefit the industry. Hi, Hugo. Welcome to the podcast. Tell us a little bit about yourself.
Hi, Janak. Thank you so much and happy to be here. Like you mentioned, I'm a product manager here at Infineon. I particularly specialize in microcontrollers, and I've been working in the automotive industry for 17 years now, and particularly working with microcontrollers over 20 years. I started my career as an embedded software developer, back when I graduated from college, until 2018, where I joined the marketing team here at Infineon in 2018. So happy to be here.
Excellent. So let's dive right into it, Hugo. So as you know, there's an ever-growing demand for performance, real-time capability, and cybersecurity in the automotive ECUs. Why don't we start there? How is Infineon addressing these challenges?
Sure. Yes, I agree with you. There is a big demand for multiple technologies all at once. And Infineon is addressing these challenges in two fronts. The first one is we have a very strong microcontroller portfolio and an end-to-end ecosystem which is built for real-world applications like driver information, HMI, body and connectivity, powertrain, electrification, and so on, right?
Mm-hmm.
And secondly, right, we have continuous innovation that helps engineering teams to deliver more performance and stronger safety and security, and more importantly, to achieve all this with a faster time to market. Now, if you look at our current microcontroller lineup, like the Traveo, PSOC, and Oryxes, right? Those are brands that we have at Infineon. You will find that those are modern, scalable microcontrollers that combine multiple technologies like multiple processing units or multi-core systems. And those are very good for real-time responsiveness, applications. But also we have integrated communication interfaces like the traditional CAN FD, LIN, and Ethernet, right? Also, right, those devices are designed to meet the most stringent safety and security requirements of the industry, right?
Mm-hmm.
So, for example, you will find that we have, portfolio devices that contain lockstep cores, or sometimes also referred as shadow cores, as well as some hardware diagnostics. For example, we have error correction coded memories, and very importantly, embedded security, which nowadays is an extremely important topic for a lot of our customers to, for example, achieve secure boot into their ECUs and also to have some cryptographic capabilities. And just as important, right, the portfolio is built for scalability. Because at the end of the day, what we see that most customers are looking for is to commonize software and tool chains, right? And that requires both things, hardware and software, like pin-to-pin compatible
Right.
devices, long-term availability to support vehicle lifetime and platform use, and so on, right? And the second front, as I was mentioning, is that the innovation, right? Just to give you an example, In today's day, right, as in-vehicle networks migrate towards Ethernet and the zonal architectures, Infineon incorporates hardware capabilities in our devices that help customers to unlock performance without overburdening the CPU. Just for example, we have integrated communication accelerators, right? We
Hmm.
have some specific IPs like direct access memory engines, bridging functions that offload the packaging and handling of all these high-speed communications across the vehicle. And finally, this hardware assists to the customers, but also we need some robust software enablement to help to deliver predictable throughput and responsiveness, right? And that's
Correct.
where we partner with software companies like you guys to be able to achieve this.
Thanks. That was a lot to take in, and it's amazing to see how much content is going into today's microcontrollers. So maybe I'll talk a little bit about how we collaborate with each other. So as you mentioned, there's a lot of capability in today's microcontrollers, but you need the software to enable that, and that's where ETAS comes in. So as a software and tools vendor, many of our solutions are directly reliant on the underlying microcontroller. And here we collaborate on quite a few things. First, in our real-time operating system. So we have a product called RTOS that involves a lot of early collaboration with you guys to ensure that our operating system is ported to new devices in a timely manner. So when Infineon releases a new microcontroller, we want to be able to have an OS that supports that microcontroller as soon as possible. Another big area that you brought up was security. That's a huge topic today, and we have a long history between ETAS and Infineon of collaborating on the security firmware side with our Secure HSM product that provides the software that runs on the Infineon HSM device, as well as you mentioned, the push towards Ethernet. Now we have new products like Secure Gate, which provide IDS capability for those devices. Another area we've historically collaborated on is our ETK product, which essentially connects to the microcontroller through the JTAG interface and enables very high speed measurement and calibration on Infineon devices. And lastly, when we talk about new technologies, like you mentioned, ETAS and Infineon talk regularly on advanced topics and areas where we can collaborate on research such as software partitioning, timing analysis, deploying software to multi-core systems, etc.
Right. Oh, thank you so much for explaining our relationship and how we've been working across the years on collaborating. But I have a question for you.
Sure.
Can you give us some real world examples or use cases in which we can help customers to deploy faster and go to market?
Yeah, absolutely. That's one of the keys. If SDV is all about speed and being able to deploy faster, right? So you hit on a key point. How does all this work together? So, previously I talked about all of these different software technologies that we have, but how is that all put together? How can that help a customer, develop a solution that fits the market needs in a timely manner? And so there's quite a few areas where we're working together. First one I'll talk about is our AutoSAR Classic starter kit. If anybody's worked with AutoSAR Classic, it's quite a big system. There's a lot of capability and there's a lot of software that a customer would need to understand. So what we do is we actually take the first step. We take the Infineon MCAL, which is the microcontroller abstraction layer, and we pair that with our RTA Car Classic AutoSAR solution and get that running on an Infineon evaluation board. So by the time the customer gets it, it's a turnkey solution where they already have software that's up and running on the Infineon hardware. It's communicating on Ethernet or CAN. The security software is functioning. And then the customers can really take that and start developing their own application on top. That's been a very successful collaboration we've worked on with you guys. The other area I mentioned are HSM software. So the hardware security module software, there's a big need for high performance. And so there is quite a bit of overlap between the software and hardware. And so we customize the HSMs for particular Infineon targets to ensure that, we're getting high performance. And that involves a lot of early collaboration between our two companies. And the goal is, by doing this early collaboration, our HSMs, ROSs, etc., they'll be ready for customers when they start their projects. They're not having to wait months for us to develop a new port or something like that. So maybe Hugo, I'm always interested in what's next. We talked about some of the new technologies. We talked about software, but really, how do you see the industry evolving? With new SDV challenges, customers may be thinking about, how do we future proof our solution so that in the future, if we come up with a new idea, how can we implement that without having to change hardware? And, how do we create scalable multi-core solutions for higher performance in the future? And really, what are your thoughts about all that?
That's a great question. And that's something that I've been thinking about for quite some time. Not only me, but also my colleagues. And we all agree that if we look ahead, we see more and more functions pull into these new electrical architectures. For example, we see some functions moving to the zone or the domain controllers, and we see that they will be interacting with a network of smart edges nodes where the quick handling and the safety is done locally, but the big decisions are actually taking place elsewhere, right? Like in the central compute or even on the zones. Um, Now, when we talk about the edges, right, or these nodes, these microcontrollers, we see changing a little bit responsibilities, and those will pre-process data primarily to enforce local safety. And also, we expect to see more mixing of critical and non-critical tasks using virtualization and partitioning. Some technologies that we have today, but also we see in the future, right, is virtualization, like the hypervisor that
Mhm.
we currently support in our devices, that allows you to do this type of partitioning, right? Also, what we see coming in is more AI, right? Especially on the edges, right? Localized, and there are specific algorithms that will benefit from AI in the edges. So certainly, it's something that I'm looking forward to. And as well as the demand for performance increases, also the demand for efficiency is increasing. So efficiency will matter. Right now, we see that it will matter as much as the speed, right? Especially for electrical powertrain, where you might be judged more on the real-time throughput, right? Per watt, not just per megahertz, right? So that's what I expect to see in the industry moving forward.
Yeah, that's really interesting, Hugo. I mean, we hardly ever think about energy usage, right? But as you mentioned, the amount of processing that will happen in the next generation vehicles will really use a lot of power, and it's a huge consideration. So you talked about virtualization. Is that on the microcontroller side, or is that more related to the higher performance compute units?
We have technologies in our microcontrollers that allow you to do virtualization. Just give you an example. Our Oryx TC4 devices have hardware built in to support hypervisor, right? But also you need software for it, right? And that's where partners like you, for instance, can help us on building the operating system that allows to have this virtualization. So it's a combination of both, right? Hardware and software.
Yeah, absolutely. There is this is a big topic for us as well, and we have a lightweight hypervisor that runs on microcontroller devices using technologies within the hardware to allow somebody to develop an ECU where you can have different domains that are separated, maybe mixed criticality, but it also allows you to develop potentially two different domain type of software without having to validate the entire software stack because they are separated by a lightweight hypervisor. So I think that's one of the key technologies that will, be part of the SDV journey. Well, Hugo, we've touched a range of topics involving how Infineon and ETAS are collaborating to meet industry needs, from higher performance needs, cybersecurity, and ease of starting new projects. It's been a really fun discussion. Thank you.
Sure, no problem. I had a great time talking about a lot of different topics like safety, security, high performance, multi-core, hypervisor. So it's an exciting time for the automotive industry. Hope we can collaborate more later. And yeah, if anyone listening have any questions, I will invite them to reach out to us or go to our website where they can look at our offering on microcontrollers for automotive.
Absolutely. I think it's going to be really fun to see where our collaborations go next. And, that's always fun for me as somebody who's always thinking about what's next. And, talking to guys like you, it's really enjoyable. So thank you so much for tuning into this episode of the Empowering Tomorrow's Automotive Software podcast. We hope you found our discussion insightful and valuable. If you'd like to learn more about this collaboration, check out our white paper and webinar recording. Links to both can be found in the episode description. If you enjoyed today's episode, don't forget to subscribe on Spotify, Apple Music, or wherever you get your podcasts. Feel free to share this episode with your network and leave us a review. We'd love to hear your feedback. Thank you.
Thank you for joining this episode of the Empowering Tomorrow's Automotive Software podcast. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about automotive embedded systems and ETAS's capabilities, visit our website at ETAS. That's ETAS.com.